Ernest Wilkins Jr. earned a PhD in mathematics at 19 years old, helped build the atomic bomb, and invented radiation shielding that protects everyone from nuclear reactors to astronauts in space. But for decades, almost nobody knew his name, and that wasn't an accident. Let me tell you how this happened, because Wilkins' story exposes something ugly about how America treats black genius. He was born in Chicago in 1923 into a family where excellence wasn't optional. His father was a mathematician and lawyer who would later become Assistant Secretary of Labor under President Eisenhower. His mother held a master's degree and taught in Chicago public schools. This was a household where intellectual achievement was the standard, not the exception, and Wilkins delivered. At 13 years old, he enrolled at the University of Chicago, making him the youngest student in the university's history. Think about that for a second. At an age when most kids are struggling through middle school, Wilkins was taking college-level mathematics courses at one of the most prestigious universities in America. He graduated with a bachelor's degree in math at 17. He earned his master's at 18. And at 19 he completed his PhD in mathematics. The national press called him a Negro genius, which tells you everything about the era he was living in. They couldn't just call him a genius. They had to racialize it, as if his brilliance was surprising because of his skin color. But Wilkins didn't have time to worry about what newspapers were calling him, because World War II was raging, and America needed mathematicians who could solve impossibly complex problems. In 1944, Wilkins was recruited to work at the University of Chicago's Metallurgical Laboratory. This wasn't some ordinary research facility. This was part of the Manhattan Project, the top-secret government program to build the world's first atomic bomb. Wilkins found himself working alongside some of the greatest scientific minds of the 20th century, including Enrico Fermi and Arthur Compton. His job was to figure out how to produce fissionable nuclear materials, specifically plutonium-239, which would be used in the bombs dropped on Japan. But here's where the story gets complicated. Wilkins had no idea what he was actually working on. Nobody told him the ultimate goal of the research. He was given equations to solve, problems to work through, calculations to verify, but the bigger picture was kept from him. It wasn't until August 6, 1945, when the atomic bomb was dropped on Hiroshima, that he found out what his work had been building toward. And there's another layer to this. In the fall of 1944, Wilkins' team was supposed to be transferred to Oak Ridge National Laboratory in Tennessee. That's where a lot of the key Manhattan Project work was happening, but there was a problem. Tennessee had Jim Crow laws, which meant that Wilkins, as a black man, would not have been allowed to work there as a scientist. The segregation laws of the South literally prevented one of the brightest minds on the Manhattan Project from going where his skills were most needed. Edward Teller, who would later become famous as the father of the hydrogen bomb, wrote a letter in September 1944 trying to get Wilkins cleared to work at Oak Ridge despite the segregation laws. Teller said that men of high qualifications were scarce and that Wilkins had been doing excellent work according to Eugene Wigner, another top physicist, but it didn't matter. The laws were the laws. Wilkins couldn't go to Oak Ridge. So instead, he stayed at the University of Chicago and worked directly with Eugene Wigner on neutron absorption and radiation shielding. And this is where Wilkins made his most important contribution, the work that would define his legacy if people actually knew about it. He developed mathematical models to calculate how gamma radiation penetrates through different materials. This sounds technical, but what it actually means is that Wilkins figured out how to protect people from deadly radiation. When a nuclear reactor operates or when a bomb detonates, it releases gamma rays, which are incredibly dangerous forms of radiation that can kill you almost instantly if you're exposed to enough of them. If you want to build a safe nuclear reactor or send astronauts into space where they'll be bombarded by solar radiation, you need to know exactly how thick your shielding needs to be and what materials will stop the gamma rays without making the structure impossibly heavy. Wilkins solved that problem. In 1953, he published a paper with Herbert Goldstine in Physical Review that laid out the mathematical framework for gamma radiation shielding. This work became foundational. Every nuclear reactor built since then, every spacecraft designed to protect astronauts from cosmic radiation, every medical facility that uses radiation therapy, all of them rely on principles that Wilkins helped establish. His calculations literally save lives every single day. But here's the problem. All of his work during the Manhattan Project was classified. Every report he wrote, every equation he solved, every breakthrough he made was stamped secret or restricted and filed away in government archives where nobody could see it. And unlike many of his white colleagues who went on to prestigious university positions after the war where they could publish papers and build reputations, Wilkins struggled to find academic jobs that matched his qualifications. He taught at Tuskegee Institute for a year from 1943 to 1944. Tuskegee was a historically black university, and it was one of the few places that would hire him despite his credentials being better than most professors at elite white universities. After his work on the Manhattan Project ended in 1946, he went into private industry, working first at American Optical Company, then at United Nuclear Corporation, and later at General Dynamics. These were good positions, but they weren't the kind of high-profile academic appointments that lead to fame and recognition. And here's where the classification issue becomes even more damaging. When your most important work is locked away as government property, you can't build a reputation on it. You can't cite it in job applications. You can't use it to win awards or secure promotions. Scientific prestige is built on published papers, on citations, on being recognized by your peers. But if your peers can't see your work because it's classified, you become invisible. Wilkins published over 100 papers during his career on topics ranging from differential equations to nuclear engineering to optics. But the work that mattered most, the work that had the biggest impact on the world, stayed hidden for decades. And by the time portions of it were declassified, the scientific community had moved on. Credit had already been assigned to other people. Textbooks had already been written. The narrative of who invented what had solidified, and Wilkins' name wasn't in it. This wasn't unique to Wilkins. This happened to a lot of black scientists during the 20th century. They were smart enough and valuable enough to be recruited for critical government projects, but they weren't given the same opportunities afterward to claim credit and build careers. White scientists could leverage their classified work into academic positions and eventually publish declassified versions of their research. Black scientists often couldn't because racism blocked them from getting the positions where that kind of visibility was possible. Wilkins eventually did get recognition, but it came late. In 1970, he became a distinguished professor at Howard University, where he helped establish the school's first PhD program in mathematics. This was a huge achievement, opening pathways for future generations of black mathematicians. In 1976, he was elected to the National Academy of Engineering, only the second African American ever to receive that honor. In 1974, he served as president of the American Nuclear Society. These are prestigious positions, and they show that Wilkins' peers in the nuclear physics community knew how important he was, but the general public, they had no idea. If you ask someone in the 1980s or 1990s to name the scientists who built the atomic bomb, they'd say Oppenheimer, Fermi, maybe Teller. Wilkins' name wouldn't come up. And that's the tragedy here. Not just that he was overlooked, but that the system was designed to overlook him. Classification served a purpose during wartime. The government needed to keep atomic secrets away from enemies. That's understandable. But classification also served to hide black contributions to science. When the work is secret, you can decide later who gets remembered and who gets forgotten. And America made a choice about who to remember. The consequences of this erasure go beyond Wilkins personally. When young black students go through school and learn about the Manhattan Project or nuclear physics or space exploration, they don't see people who look like them in those stories. They're told implicitly that these fields belong to white men. And when they don't see themselves represented, they're less likely to pursue those careers. This is how you perpetuate inequality across generations. You erase the black scientists who made the breakthroughs, and then you use that absence as evidence that black people aren't suited for science. But Wilkins proves that narrative is a lie. He was smarter than almost everyone around him. He entered college at 13. He earned a PhD at 19. He worked alongside Fermi and Wigner and held his own. He solved problems that other people couldn't solve. And he did all of this while navigating a country that told him at every turn that he didn't belong. In recent years, historians have started to recover these hidden stories. Wilkins got a brief mention in the 2023 film Oppenheimer, where he's portrayed by actor Ronald August. That's progress, I guess, but it's not nearly enough. A 30-second appearance in a 3-hour movie doesn't make up for 60 years of being written out of history. What would make up for it is teaching his story in schools, putting his name in textbooks alongside the other Manhattan Project scientists, explaining to students that nuclear reactors are safe because a black mathematician figured out how to shield people from radiation, telling kids that when astronauts go to space, they're protected by calculations that Wilkins helped develop, making sure that when people think about American scientific achievement, they understand that black scientists were central to it, not footnotes. Because here's the reality. Wilkins' work powers the modern world. Every nuclear power plant generating electricity right now is using principles he helped establish. Every spacecraft protecting astronauts from cosmic radiation is applying his calculations. Every medical facility using radiation therapy is relying on shielding techniques he pioneered. His genius is everywhere, even if his name isn't. And he kept working until the end. He retired from teaching at Clark Atlanta University in 2003 after spending decades mentoring young black students and encouraging them to pursue mathematics and science. He died in 2011 at the age of 87, having lived through nearly a century of American history and having contributed more to science and engineering than most people could achieve in 10 lifetimes. But the question remains, why did it take so long for people to recognize what he'd done? And the answer is uncomfortable but clear. America has always been better at using black genius than at acknowledging it. Wilkins was valuable enough to recruit for the Manhattan Project, but not valuable enough to put his name on the work. He was smart enough to solve problems that stumped other scientists, but not white enough to get the credit he deserved. Classification was the mechanism, but racism was the motive. The government could have declassified his contributions earlier. They could have made sure his name appeared in histories of the Manhattan Project. They could have ensured that when the story of nuclear science was told, Wilkins was included from the beginning. But they didn't. And that wasn't an oversight, that was a choice. So when you hear about the atomic bomb, or nuclear power, or space exploration, remember J. Ernest Wilkins Jr. Remember that a 19-year-old black mathematician helped make all of it possible. Remember that his brilliance was used and then hidden. And remember that there are probably dozens of other black scientists whose stories we still don't know, whose work was classified and forgotten, whose names were erased from the record. The challenge now is to bring those names back, not as footnotes or curiosities, but as the central figures they always should have been. Because science isn't just about discoveries, it's about who gets to claim them. And for too long, black scientists were denied that right. Wilkins' story is a reminder that genius doesn't care about race, but history does. And if we want a more honest history, we need to start telling the truth about who built the world we live in.